Swayam Prabha. Digital India. Educated India.
Okay, so welcome back. So we'll continue our discussion where we left in the previous video in terms of feedstock recycling. We were looking at pyrolysis and plasma like a technique as well. So in this we'll kind of cover about a little bit more discussion on pyrolysis, the advantages, disadvantages of pyrolysis system, and we'll move to waste to energy, which we'll talk about. So let's look at the detail in terms of advantages of pyrolysis. One of the good thing about is that we can use mixed plastic here. We don't earlier in the mechanical recycling, if you remember, we had to separate the different plastic types. Here we can use mixed plastic because the focus is here to do the resource recovery in terms of the energy and some products. So you can use mixed plastic. And we can even the plastics which cannot be effectively recycled by alternative means, this can be used in that area as well. So as you can see, like even mixed plastic that we can use, which cannot find other method, we can use it over here. And we can also do it for unwashed and soil plastic. Like agricultural plastic mulch is used, silage, greenhouse films and drippers and irrigation tubes. So when anything which has some waste like some soil, some dirt attached, we can use that too. Although yes, our the char that will be produced will have those impurities showing up there, but that's for most part it will be okay. And you can do plastic laminates, co-extrusion and multi-layer packaging films, particularly those with aluminum foil layers that are difficult to recycle. So there is a lot of flexibilities there in terms of the pyrolysis plants, which you can use for your application. So in terms of since there are the advantages, there will be disadvantages. So in terms of the disadvantages, it's complex. As you saw the video just before, both the videos, there was one from that Chinese company and then one from our lab, one of the Indian research labs. So you saw that there is a lot of components there. It's a heavy duty. It's a little bit high tech. So it's a complex, requires high operational and investment cost, and also you need skilled manpower to run it. So it's and you need to have air purification system, which you need to make sure that air pollutant is not that high. So that needs to be treated. Whatever the char or the ash that you produce may end up having high heavy metal that may create a problem, because you have high heavy metal content that you need to treat that. You need to make sure that you manage that high heavy metal content material properly. Then you have if you don't have, you cannot have it needs to be a continuous process. You cannot have it like you start it, stop it, start it, stop it. That doesn't work. So it needs a continuous process. And the continuous process, if you cannot, so what does it mean? That means that you need to have a good supply of plastic waste. In the plastic waste, there has to be like a continuous supply of plastic waste. So in one way, we can say that it kind of discourages improving recycling. But you can think in that angle. But if you look at from a practical point of view, there are a lot of plastic available in the waste stream, which is very difficult to recycle. As you just saw in the previous slide, there is a mixed plastic, there is aluminum foil in between, there are different materials in between, which it's difficult to separate all of them out and use it like one material at a time. So in pyrolysis system or some pyrolysis type of system, you can mix them all together and then it still works. So but yes, you need to have that plant running all the time. And you will have some caulking and carbon deposits on the heat exchanging surfaces that will create some problem. Sand particles may get into fluidized bed process and then also create some issues associated with that as well. So these are some of the disadvantages of pyrolysis process, but it is a good candidate especially for mixed plastic. So other than that, if you don't go for pyrolysis, what are the other things you can do with mixed plastic in particular, or maybe plastic other like dirty plastics which cannot be recycled? You can go for incineration, so which is very similar to actually essentially the same, the incineration plant that we talk about for a waste, municipal solid waste or waste to energy, that is kind of focused a little bit in India in last decade or so. During one of the budget by, I think at that time it was Mr. Chidambaram was the finance minister. So he had announced that India will focus on waste to energy, and a special incentive for waste to energy plants were also talked about in that budget. And since then, subsequent budget until today kind of has a lot of focus on waste to energy. Even Niti Aayog came up with a report on burning all the garbage, although I have some issues with that report, which we talk about in that waste management class. But this is incineration is also one aspect which can be looked into, should be looked into. And as I said in the last video, see, we are academic people. We don't have any biasness for any technology. We look at different technology. We have look at the pros and cons of different technology, and then we can suggest which technology will work best in what condition, because we are not selling here any technology. So I'm not saying that this technology is good or that technology is bad. I'm just saying that these are the pros and cons of different technologies, and that's how, and we need to evaluate, and based on the situation, some technology will be preferable than the other, and that we can always discuss. So incineration plants, waste to energy plants, which is pyrolysis was in absence of oxygen. Waste to energy incineration plant is actually in presence of oxygen. So here you are doing it in presence of oxygen in excess amount, where you do the thermal treatment, thermal degradation of the waste in the incineration. So you are adding air. We don't have, so when we say adding oxygen, so we are adding air, so we have to supply air, and it's essentially combustion. It's a combustion process. So as you know, combustion is an oxidation process, so air is required, oxygen is required. So, and incineration, there will be a chemical reaction which will hydrogen, carbon and other elements in the waste will be combusted, and heat will be generated based on the calorific value. Since plastic has good calorific value, so you will have decent heat generated, and then you will have carbon dioxide, CO, oxides of nitrogen, water vapor, and then some principal gas. There also you will have some traces of you will have dioxins, furans and other things also coming out, especially if you are working at lower temperature. That's why we work typically at pretty high temperature compared to other systems. So we are looking at 1000 degree and above, 900 to 1100 degrees centigrade. So what it does, it makes sure that you have proper combustion and you have elimination of odor. Again, this is sorry, it's odor. It's a smell, elimination of odor from waste. So there is and there are three major things that we need to design for: temperature, turbulence, time. That's called 3 T's of combustion. 3 T's of combustion: temperature, time and turbulence. So you have to have a proper temperature. You need to give it time for the waste to react, waste to get combusted based on kinetics. And turbulence means mixing. So you have to have a proper mixing of waste before mixing of waste so that the reaction is complete. So you don't have incomplete combustion happening, because that will create problem in terms of more air pollutants showing up. So incineration technology, there are a number of options are there for the MSW, municipal solid waste incineration plant technology, and there are mass burn is most common, where you have a mass burn technology. There are new technologies that are also developed. Some of them are complicated, costly for developing country to execute, but most common is either mass burn or refuse derived fuel. And some cases you may have to do some pre-treatment as well. So if you look at the equipment in terms of a incineration plant, you are looking at there are four major components in terms of the equipment here. One is our pre-treatment, then you need to have a combustion system, energy recovery system, and a flue gas cleaning, which are the four major categories that you have to focus on. Pre-treatment means once the waste comes in, you want to make sure it does not have any component which will create problem in the combustion chamber. So before it goes to the combustion chamber, before waste goes to the combustion chamber, we have to make sure that there is nothing in there which will create problem in terms of a small cylinders or some aerosol cans and those kind of stuff which will kind of have a blast and other stuff. So that needs to be taken care of. Also we need to take care of if we have too much moisture, because too much moisture means what? Moisture, latent heat of vaporization. So your net energy gain is going down. So you don't want that to happen. So if you have too much moisture, you need to dry it. So that kind of treatment is required. And so those and if you go for RDF facility, which is called refused, if you go for a refuse derived fuel facility, it's RDF. If you go for a RDF facility, which is known as refused derived fuel facility, you will also may have a pre-treatment where you will have shredder, separators, different. You want to make a homogenized size, either use it as it is or pelletize it together and use it in a pellet form. So we discuss those things in more detail in our waste management course, like a general waste management, which is called integrated waste management for smart cities. So that in that course we kind of cover more in detail. That course will be rerun again in July. So those of you who have not taken it previously may want to take it. So there we talk about incineration in great detail. Here we are just talking about how the plastic waste can be managed using an incineration technology. So you either you will take all those hazardous things out, you will take make the moisture content go low, or if you are going to use for RDF, you will shred it, and rather than using a mass burn facility, you will use an RDF facility, which is a refuse derived fuel facility, which increases your efficiency of the system. But then again, you need to put all the earlier system in place to make RDF, which has the cost as well. So you have to do that economics, you have to do the optimization, which one is good. Either we put a system in place to make RDF and get a little bit of more energy, or whatever is the more energy, and then, or we just go for mass burn and we have a energy level, energy gain is less, but then you don't have to put all that investment in place for producing RDF. So there is pros and cons of both, which needs to be debated and discussed and calculated based on your situation. So this is a typical waste to energy process where you have your garbage bunker coming in. It's where you have the waste coming in. So this is your garbage getting stored over here. So this is a huge bunker, and just after this I will show you the video of Amsterdam waste to energy plant, which is an animated video from Amsterdam, which is in Netherlands, and I want you to watch it very carefully. And if those of you who will travel to overseas at any point in your life and you really want to see one waste to energy plant in your life, go and see that Amsterdam waste to energy plant. You guys may be thinking I'm crazy, but since I'm essentially a garbologist working with different garbage, so I really get fascinated by these plants, and I try to visit them. So I've been to Amsterdam plant 2 times already, because and every time you go there you learn something more. So it's so this is we'll see a small video on that after this slide. But this is garbage bunker where the waste is getting into the boiler, which waste is getting fed into the boiler. Then you apply air through there is an air supplier. You have a great firing happening inside this stuff where the waste is being treated. And once it's treated, you have the heat is used in the boiler for energy production, and then air pollution that is coming out goes through your fabric filter and goes through some other reactors and other filters, and then finally it goes up from this stack outside, whatever is air pollutant, after getting through the air pollution control system. you also have some secondary air for exhaust gas purification and all that. So this is how just a very quick, it's a very simple sketch for a waste to energy plant. So essentially you have a feeding system, you have a combustion system, then you have an air pollution system, and the heat generation will go into the boiler, from boiler to electricity generation. You can use the heat by itself for house heating, which is also called district heating system. So that's kind of gives you an overview of a waste to energy process which can be used for plastic waste. And again, here we can also use mixed plastic. We don't have to separate PET, HDPE, LDPE, PP and all that. We can use mixed plastic as we could use it in the pyrolysis plant. So let's, I think we'll have a quick, like you go over this video, and again I will keep quiet. I want you to watch it. It has audio which will go through the whole process, and once you go through this, we'll discuss a little bit more. And in case you want to learn more about waste to energy, as I said, there are resources available. One of the resources, our NPTEL course, which is already you can find YouTube videos of that, and you can look at that waste to energy processes in a little bit more detail. So let's look at this video, and then we'll discuss the component of it.
Welcome to the Waste and Energy Company in Amsterdam. More than 1.5 million tons of domestic and commercial waste is processed here each year on 6 incineration lines. Waste lorries and trains bring in the waste. It is important for optimal incineration that the waste is of a uniform quality. This is why it is mixed in the waste bunker. Large grippers then transfer the waste mixture into the hoppers of the furnaces. The waste is incinerated on grates. This is a continuous process, 24 hours a day, 7 days a week. Temperatures range between 1000 and 1200 degrees Celsius. This heat is not wasted. It turns water in the furnace walls into steam. This steam passes through the 3 turbines at high pressure, and the turbines drive a generator. This generates enough electricity to power 161,000 homes every year. After the electricity has been generated, the residual heat is used to produce heat for the city. This is piped to the district heating system in Amsterdam and provides warmth for 15,000 homes. Part of the waste is incombustible. This part which remains after incineration we call bottom ash. Technology developed together with Delft University of Technology is used to wash and recover metals from the bottom ash. Large amounts of iron and non-ferrous metals such as aluminium and copper, are returned to the scrap metal trade for recycling. The rest is cleaned further until clean sand and a stony granulate remain. High-quality building materials which are used, for example, in concrete and asphalt. After the incineration process, the flue gases are cleaned. This is the longest part of the whole production process. And all done to ensure that almost nothing is released from the chimney. There are strict government regulations. Emissions from the waste-to-energy plants remain well under the limits, and we continue to work on improving this. The flue gases are cleaned in a number of stages. We aim to recover useful products at each of these stages. First of all, flying particles are removed using an electrostatic filter placed behind the furnace exhaust duct. This fly ash is used as a filling material in asphalt. Dioxins, heavy metals and other environmentally harmful materials are then removed from the flue gases. Plaster and salt for de-icing are recovered in the process and used in industry. The water necessary for the process is recycled in a closed system. The installation therefore produces no wastewater. A sensor in the chimney constantly measures the quality of the discharge gases. The white plume of smoke is in fact nothing more than basically pure steam. Only about 1% of everything that enters the waste-to-energy plant is actually left over. This is completely unusable and is disposed of safely. 99% of the waste is converted into sustainable electricity, heat, and useful building materials.
As you saw the details, it's one of the most comprehensive waste to energy plant in the world. So that's the reason I wanted you to watch this one, not the other. There are a lot of other waste to energy plants. There are 3 or 4 working in India right now. Jindal plant in Delhi, ILNFS plant, and I think there is a Ramki plant as well in Delhi. So those 3 are working. There are some other plants in pipeline in India as well. But in terms of the whole comprehensive, whereas you saw in this video from the very beginning, the waste that is coming in, all the way to even management of those residual, the ash, you saw that they were separating the ash into different fractions. Different fractions is used for different application. So amount of waste that comes into that plant, only 2 to 3% really ends up as waste. So it is mostly towards like a zero waste concept. And these things takes time. We like many times the students may come up with questions on discussion forum or during our live session saying that why can't we do it in India? We can do it in India. We can have similar plants in India. We can do for municipal solid waste. But thing is that our calorific value is very low. Our waste calorific value is pretty low compared to European system. Our waste collection system is not proper because everything gets mixed up together. That's the reason why our calorific value is low. Our waste is not covered. We get a lot of moisture coming into the waste. The type of food that we ate also has a lot of moisture. So overall we have moisture content is much higher. That again lessens the calorific value. So because of those kind of factors, many of these plants in India struggle to have a economical viability over a long term. So being said that, it's still waste to energy can be done in certain sectors in the country based on the calorific value numbers, and to setting this whole system in place where you have a gas collection, where you have the waste combustion, then you have the heat recovery, energy production, residual ash recovery, as well as using that ash for different application. The whole process it's a complex process. And as the waste to energy industry evolves in country like India, we'll have those plants coming up maybe in 10 years, 15 years from now, where you will have the entire things taken care of, part of like a circular economy concept, where things are being, rather than having a linear economy. So we'll talk about that in our last week as well when we talk about circular economy concept. So now what are the advantages of incineration of plastics? It's high calorific value. Plastics are essentially coming from crude. It's the petroleum based products. So since it's a petroleum based product, they have high calorific value. So they do have a high calorific value. So that helps in producing high amount of energy. And when you do this destruction, you will have thermal decomposition of organic material. You have CO2 being produced. Methane, you will not see methane in the waste incineration plant, but methane might be there from the bioplastics when we go for like a anaerobic digestion. That's where, so methane here may confuse you. So just wanted to make sure you don't get confused with why methane has been put here for a waste to energy plant, for the incineration plant. It's not that much relevant for incineration, but when you go for waste to energy for using an anaerobic digestion, especially for bioplastic, which we'll talk about in the next week, where there we'll talk about this more. So when you look at this bioplastic, which is the biodegradable plastic, when you go for anaerobic digestion, there you will have methane showing up. In incineration, you will have mostly CO2. So just wanted to make that clear so that you don't get confused. So it's methane is anaerobic digestion, CO2 is mostly by thermal decomposition. So when you have the thermal decomposition, it's mostly CO2 of the organic material, and energy can be captured by further power and heat requirement. So generation of power, income and creation of jobs, which are because of waste to energy. Energy from waste projects provide a substitute for fossil fuel, can be that's it, you can use it for a fossil fuel. Volume of waste is reduced. In addition to burning, high temperature environment led to the decomposition of toxic plastic components such as benzene. So when you burn it at a high temperature, you get rid of certain toxic material in terms of when you burn them. So disadvantage of incineration: plastic is easy to burn and it produces toxic gas such as styrene produced during the combustion of polystyrene can cause styrene has a problem, like a styrene gas can cause a lot of impact in terms of impacts our vision, vomiting, other symptoms of inhalation. PVC burning produces toxic hydrogen chloride gas. High temperature environment led to decomposition of toxic plastic components such as benzene. So this is that's actually in a that helps in reduction of benzene. Implementation of air pollution control equipment, it adds to cost. So that is there. The cost goes up in terms of installation. Do you require a skilled technical labor in operation of the plant? Process demands continuous supply of waste, and then so encourages its production. So essentially it if you that is the common problem, the common, I would not say problem, the common criticism that we get for waste to energy plant is it actually it's a negative to recycling, because most of the plastic which is we are talking about today, and also other components, if you look at the paper, textile and those, they have good calorific value. Plastic has pretty high calorific value. So if I am setting a waste to energy plant to deal with plastic waste along with my other municipal solid waste components, the recycling process of plastic may get a negative kind of push. People will try to send things to the incineration plant and not worry too much about recycling, doing the recycling better. That's a general argument which you hear at many platforms in terms of plastic waste management. But at the same time, we also see that there are, as you saw in the kind of one of the slide in the previous video, that only 18% of the plastic is getting recycled. So out of 100%, 82% is still not being recycled. So they are ending up in landfill, they are ending up in the waterways. So even if we go from 18% and improve our recycling rate to 36%, 40%, 50%, rest 50% of the plastic needs to be managed too. So if you look at from a practical point of view, from an operational point of view, recycling and waste to energy both has its place, and both system can be used. So we talked about recycling in the first video, and then we have talked about waste, in this second video, and we talked about this waste to energy in this present video. And so if you look at in isolation, you kind of feel like, oh, they are both competing with each other. So if my recycling is getting better, my waste to energy will suffer. That's how it looks like. But in practical sense, since our recycling is so low, even if our recycling improves, still we have a lot of material out there which could be used in waste to energy plant. So that's how the waste to energy can still be a good proposition for treating waste like plastic waste. The issue for waste to energy plant, as we just discussed few minutes back in Indian context, is since the calorific value is so low, it becomes difficult to manage this kind of plastic, this kind of waste in general, which plastic does not come in isolation. Plastic is there with other, you have your papers and other stuff, and since we have the food waste and yard waste and street sweepings, everything mixed together, and it becomes problem in terms of low calorific value, and those plants does not really work very well from a economics and as well as operational point of view. So with that, let's stop this discussion for this particular video right here. So we talked about recycling, we talked about incineration, then in next we'll look at landfilling, and then we'll also look at use of plastic waste for different application like road making and all that. So thank you. I hope you're enjoying the course. Any feedback, may you put it on the discussion forum. We'll be happy if there is something we can do to help your learning in this course, we'll do that. There is a reading set of reading material, the PDF files, other than these lecture slides for each week, and those are also on the web. So don't forget, for each from week 1 until week 8, every week we have a set of PDF 4 to 5, 6 files or around that number for each week. Sometimes you may have same file showing up in multiple weeks because we have referred to them in multiple weeks, and those are background materials kind of on top of this slide. So I encourage you to read that and encourage you to refer that if you want to have a greater depth knowledge of this particular course. And you can ask questions from those if you don't understand on the discussion forum as well during the live session which we will schedule. You will have live session in this course as well. So thank you, and see you in the next video.